Hi class, for this lecture we're going to be looking at a couple of problems that involve integrals, vectors, and work. Now, for the very first problem, we're just going to be looking at a function, and then we're going to calculate the total area under the curve. So for this problem, we're simply looking at the actual integral from 0 to 1 of the function f of x dx, which translates to the integral from 0 to 1, and then we're integrating an x to the third minus a 2x squared plus the values of x, and then technically dx. So at this point, we're just going to end up with an x to the fourth over 4 minus 2x to the third divided by 3 plus x squared over 2 evaluated from 0 to 1. Notice that the lower bound at 0 represents this point here, and then everything's going to actually cancel there. So evaluating 1, we're simply going to get the upper limit of 1/4 minus 2/3 plus a half, and then technically minus the values of 0. Our LCD is equal to 6, so it's equal to 12, which means that we're going to multiply times 3 on this one. We're going to multiply times 4 and times 6 times 6. So we're looking at this one being a total of 3 12s minus 8 12s plus 6 12s, or in this case 9 minus 8, 112. Now, remember that we're working on an application, so all applications should have some sort of a sentence. Since you're just looking at the total area under the curve, in this case, we're simply looking at this portion here. We're just going to say that for this one, the total area under the curve for f of x from 0 to 1 is a total of 112, and I'll just leave it as units. We're not asked about or we're not told about any other measurements such as meters. So in this case, we'll just leave it as units. And it's technically units to the second power because of area. So let me write it. And that's actually it. So regular integral, regular application from Calc 2, area under the curve. Once again, don't forget that we're doing an application, so some sort of a sentence that states the answer will be needed. That's actually it for this one.